Hi there, this is the Aptitude guy. Welcome to another lesson video on quantitative aptitude. This is part 2 on the topic of units place. If at all you have not watched part 1, please definitely go back and watch that. I'll link the video in the I button over here. If you haven't watched it, make sure you watch it. It has all the basic stuff that you need in order to solve the questions in this video. Alright, now without any further ado, let's solve some more questions on units places using power cycles. Let's get started. Alright, this is question number 1. Pause the video, try to solve it and then come back. You know the drill. Alright, let's do this. The question is 777 to the power 777. Nice. And if I remember correctly, this was one of the extra questions in the previous video, right? Let's see if you got the right answer. The first thing we do in such questions is write down the power cycle of the base value. The base value over here is, of course, 7. 7 power 1, 7. 7 power 2, 49, so 9. Then 9 sevens are 63 and then 3 sevens are 21. This is the power cycle of 7. If you do not understand what this means, then like I said, definitely watch the first video and then come back over here. Now, how do we simplify this number? The number is 777 to the power 777. The first thing we do is we only take the base value. So this gets simplified to 7 to the power 777. Now what do we need to do? The power cycle of 7 has 4 terms. And whenever the power cycle has 4 terms, we divide the power by 4 and get the remainder. Now in the previous video we learned that we don't need to divide the entire number by 4. What do we need to divide? We only care about the last 2 digits. And why do we do that? Because 4's divisibility rule states that we only care about the last 2 digits. So this can be simplified to be 77 divided by 4. And 77 by 4, what is the remainder? We know that 76 is divisible by 4. Alright, so 77 by 4, the remainder will be 1. So what is the final answer? So 7 to the power 777 is equivalent to 7 to the power 1, which is equal to finally 7. The answer is option C. Now, the most complicated part about this one, which is not really that complicated, but still, people find trouble doing this part, 77 divided by 4. Now, if at all you are doing the long division method, that is 77 by 4, then 4 ones are 4, and so on and so forth. If you're doing it by the long division method, it's not wrong, but it's just boring and time consuming. I'll tell you a slightly better method to do this without using much of pen and paper. I will write it down, but to tell you how to visualize it. Okay? So we have 77 over here. Take 77. Now the first thing you do is take 40 out of 77 and throw it off out of the window. Why? Because 40 is divisible by 4. That means 40 by 4, the remainder is a big fat 0. So we don't care about 40. How much remaining? 77 minus 40, we have 37 remaining. Now this 37 is on the hot seat. Out of 37, how much can we remove? We can easily remove 36. Why? Because again, 36 by 4, the remainder is a 0. So what are we left with now? 1. And that is the remainder. Done. You don't need long division method to find remainders. We have 77, 40 gone, 37 remaining, then 36 gone, 1 remaining. Done. 7 to the power 1, 7 is the answer. I hope this makes it much more clear for you. If not, definitely drop your doubts in the comments. I'll try to answer them. And if this is 100% clear to you, then let's see if you can solve question number 2. Pause the video, try to solve it, and then come back. Alright, let's do this. Now, what are the base values in this question? We have 3 and we have 7. So first, let's write down the Power cycles of 3 and 7. 3's power cycle is 3, 9, 7, 1. And 7's power cycle we did in the previous question itself. We have 7, 9, 3, 1. Okay, let's simplify this now. We have 3 to the power 1001 into 7 to the power 22002 into, do we need the entire 13 over here? No, this 1 is useless. We directly deal with 3. So 3 to the power 333003. Now when it comes to the powers, do we need the entire power? 3 and 7, both of them have power cycles of 4 terms. That means we need to divide the powers by 4. And we already know what is the divisibility rule of 4. Divisibility rule of 4 is that we only care about the last 2 digits. So do we care about the entire number? No, we can directly take the last 2 digits. That is how we save our time. Alright, let's do this. So this is equivalent to 3 to the power 01 into 7 to the power 02 into 3 to the power 03. That's it. Now do we need to divide them by 4? No, they are already in remainder forms. Now tell me, what is 3 to the power 1? 3 to the power 1 is 3. 7 to the power 2? 7 to the power 2 is 9. And 3 to the power 3, we have 3 over here. 3 to the power 3 is 7. That's it. Very simple now. 3 nines are 27. So that ends with 7 into 7. 7 sevens are 49. That ends with 9. That is the answer. Answer is option D. You can do it exactly opposite also. 7 nines are 63. That ends with 3. 3 threes are 9. So that again ends with 9. Done. Any doubts over here? Definitely drop them in the comments. And if at all, the question ends up becoming plus and plus over here, you will have 3, 9 and 7. Instead of multiplication, you simply have to add them. That's all. Nothing else. Let's move on to the next question. Alright, pause the video, try to solve it and then come back. Let's solve this now. We have 3 base values, 2, 3 and 4. Let's write all the power cycles quickly. We have 2 over here. 2's power cycle is 2, 4, 8, 6. 3's power cycle is 3, 9, 7, 1. And 4's power cycle is an interesting one. I hope you remember. We have only 2 elements in 4's power cycle. We have 4 and we have 6. That's all. And what did we learn in the previous video? We learned that 4 to the power odd number always ends with 4 and 4 to the power even number always ends with 6. Alright, so let's simplify this question. First step of simplification, we have 2 to the power 222 plus 3 to the power 333 plus 4 to the power 444. Now in the examination, you don't have to write each and every step obviously. One good thing about aptitude tests is that nobody cares about your steps. You only care about the correct answer or the wrong answer. I'm writing all this for explanation purposes. In the exam, you can skip a lot of steps, not an issue. Now, further simplification is what? 2 to the power, we only care about the last 2 digits because 2's power cycle has 4 terms. So we have 2 to the power 22 plus 3 to the power 333. 3 has a power cycle of 4 terms again. So we have divided by 4. So again, we care about the last 2 digits only. So 3 to the power 33 plus 4 to the power what? Do we care about the last 2 digits over here or do we only care about odd or even? We only care about odd or even. Remember, when the base value is 4 or 9, we only care about the power being odd or even. That's all. Now 444 is odd or even? It's obviously even. Now let's solve it. We have to do 22 by 4. 22 by 4, what is the remainder? The remainder is 2. Then we have 33. 33 by 4, what's the remainder? The remainder is 1. And even is even. That's all. So when we simplify this, what do we get? 2 to the power 22 becomes 2 to the power 2 plus 3 to the power 33 becomes 3 to the power 1 and 4 to the power even becomes 4 to the power even, that is 6. So this is equal to what? 2 power 2 is 4 plus 3 power 1 is 3 plus 6. 4 plus 6, 10. 10 plus 3, 13. So the final answer is 3. The answer is option A. Done. This is how it is solved. First, we write down the power cycles and then we solve it accordingly. Very simple stuff. Any doubt in any particular step that you did not understand, definitely ask me in the comments. I will answer it. If you don't have any doubts, wonderful. Let's move on to the next question. All right, in this question, we are dealing with factorials, not power cycles. Pause the video and try to solve it. Let's see how many of you can, and then come back. All right, let's do this. Very interesting question. We have 1 factorial plus 2 factorial plus 3 factorial all the way up till 2010 factorial. You have no idea just how huge this number is. If at all you write down this number totally, it will cover your entire house probably. It's insane how big this number is. More than crores and crores and crores of digits. Alright, and we have to find the last digit of that huge number. Is it difficult? Absolutely not. I have this theory about this topic. If a number is so huge that even your calculator cannot comprehend it, that means it's a very simple question. Okay? Let's see how we solve it now. First of all, let us talk about factorials a little bit. Okay? What is 1 factorial? It's 1. 2 factorial? 2. 3 factorial? 6. Factorial means what? If I have 5 factorial, 5 factorial is 5 into 4 into 3 into 2 into 1. So whatever factorial it is, it gets multiplied with every number till 1. That is all that it is. So 3 factorial is 3 into 2 into 1, which is 6. Then we have 4 factorial, that is 4 into 3 into 2 into 1. 4 6 are 24. Then we have 5 factorial, 5 into 24, 120. 6 factorial, 720. 7 factorial, 5040, and so on and so forth. Now, do you see something common over here, starting from 5 factorial? Yes, all of them end with 0. 5 factorial ends with 0, 6 factorial, 7 factorial, every factorial after that ends with 0. Why does that happen? Like I said, 5 factorial is 5 into 4 into 3 into 2 into 1. What is 5 into 2? 5 into 2 is 10. And then 10 multiplied with anything always ends with 0, of course. And after 5 factorial, every factorial has 5 into 2. That means every factorial has 10. And 10 into any natural number ends with 0. So what does that mean? That means if at all we have n factorial, and if n is greater than or equal to 5, then n factorial ends with 0. This is a rule. Okay? So when n is greater than or equal to 5, n factorial ends with 0. So we will use this to solve this question. Let's do this. We have 1 factorial plus 2 factorial plus 3 factorial plus 4 factorial plus 5 factorial all the way till 2010 factorial. Now what do we have here? We already know 5 factorial, 6 factorial, 7 factorial, 8 factorial, 550 factorial, whatever factorial after 5 factorial, it ends with 0. Now 0 plus 0 plus 0 plus 0 plus 0 plus 0 plus 0 is what? It's nothing but a big fat 0. Now if this is a big fat 0, all we need to care about is 1 to 4 factorial. That's all. Done. What is 1 factorial? 1. What is 2 factorial? 2. What is 3 factorial? 6. What is 4 factorial? 24. And we only care about the units place, so that is 4. plus this whole thing is a 0. Now what is this? 0 plus 6 plus 4 is again 10, ends with 0. So all this is gone. We are left with 1 plus 2, that is 3. Or 1 plus 2 plus 6 plus 4 plus 0 is 13, that also ends with 3. The answer is option A. Done. You know what that means? Even if in place of 2010 factorial they had given 9999999 factorial, it wouldn't have changed the answer because this also ends with 0. It doesn't matter what it ends with after 5 factorial. The answer would be 3 itself. Alright, so this is an example of a question which did not use power cycle at all, but still it's a units place problem. Any doubts over here, definitely ask me in the comments. If there are no doubts, let's move on to question number 5. Alright, pause the video, try to solve it. Here the factorials are in the powers. Be careful. Alright, let's do it. Now we have 4. What is 4's power cycle? We have 4 and 6. We have odd and we have even. And this one is 6. 6 is a beautiful number over here because 6 power cycle has only one term. That is 6 itself, because 6 to the power anything ends with 6. Alright, now let's do it. First level of simplification, only the base value. So we have 4 to the power 1, 2, 3 factorial into 6 to the power 1, 2, 3, 4, 5, 6 factorial. Wow. Now first and foremost, which is the easiest one over here? Obviously this one. 6 to the power anything ends with 6. So this part is 6 for sure. Now here 4 to the power 123 factorial, and for this we only need to care if the number is odd or even. Now many people make the mistake of thinking that 123 factorial is an odd number. Then they get 4 to the power odd number is 4, then 4 6 are 24, so they give the answer as option A, which is the wrong answer. Please don't make that mistake. In the previous question we learned something. What was that? We learned that after 5 factorial, every factorial ends with 0. So, if after 5 factorial, every factorial ends with 0, doesn't 123 factorial also end with 0? Of course it does. That means 123 factorial is an even number. Got it? I will write it down also just for your benefit. Remember it like this for later on. 123 is an odd number. Yes, but this is not 123. This is 123 factorial. 123 factorial is an even number. Be very careful with it. Okay? In fact, I'll tell you something even more crazy. Actually speaking, starting from 2 factorial, every factorial is an even number. Look at it. 2 factorial 2, 3 factorial 6, 4 factorial 24, and after that obviously they are all even. So there are only 2 factorials which are odd numbers. That is 0 factorial, which is equal to 1, and 1 factorial, which is equal to 1. These two are the only odd factorials. Other than these two, every factorial is an even number. Why? Because ultimately everything gets multiplied with 2. And you multiply any natural number with 2, the product has to be an even number, right? So that brings us to another nice property of factorials. That is, if n is greater than or equal to 2, then n factorial is even. Done. So what do we learn from this? We learn that 123 factorial is an even number, so this is 4 to the power even number. And what is 4 to the power even? 4 to the power even is 6. So we have 6 into 6. The final answer is 6. That's it. A lot of people mark the answer as 4 over here because of this mistake. But please learn, if at all this was 4 to the power 123 only, answer would have been 4. But since this is 123 factorial, That is an even number. The answer is 6. Done. All right. So with that, we are done with units places. And of course, as usual, we have a bunch of extra questions over here. Now you know more about this topic, so definitely try to solve this question. All right. And like I said, you will be able to solve such questions by the time you are done with units places. I told this in the beginning of the first video. Now you see, I can promise you, you will be able to solve these kind of questions. So of course, solve them and drop your answers in the comment section. I'll tell you if you're right or wrong. Thank you so much for watching both these videos. And if at all these videos were helpful to you, definitely like them so that the video stays in your liked video library in the YouTube app, so that whenever you need to revise, you know where to find it. And if you're liking the other videos also, definitely consider subscribing. If you want to watch the previous video, it's right here. If you want to watch the next video, it's right here. Alright, so until next time, I'll see you in the next video. Bye bye.